Okay, so now we will be starting. Good afternoon, everyone, and a very warm welcome to all of you joining us today for this special session of SAIARD webinar series. On behalf of SAIARD RSIGST, I thank you all for joining here today. I am Avantika Ganguly, Research Associate, RSIGST SAIARD, and I have the pleasure to hosting this session. Today's webinar is on a very relevant and timely topic, application of Google Earth Engine for water resource management. Water is one of our most critical natural resources, and with the growing pressure of climate change, population growth, and urbanization, managing it efficiently is becoming an urgent necessity. Tools like Google Earth Engine, with its ability to process and analyze vast geospatial data set in the cloud, are transforming how we approach water governance, monitoring, and planning. So now it is my privilege to introduce our speaker for the day, Dr. Sachidanand Singh. Dr. Singh is working as Scientist B at the National Institute of Hydrology, Western Himalayan Regional Center, Jammu. He specializes in hydrology, environmental monitoring, and the use of remote sensing GIS technologies for water resource management. We are honored to have you here with us, sir, today to share your expertise and experiences. Now I would request Dr. Singh to proceed with the session. Over to you, sir.
Thank you, Ayantika Ganguly. And thank you, SAIARD RSIGST for inviting me for this webinar. Am I audible? Is
yes,
my
sir,
sound
you're
audible? Okay, so I'm sharing my screen.
Sure, sir.
Okay.
I would like to request participants to kindly on their video cameras.
Okay, is my screen visible?
Yes, sir.
Okay. Fine. And is the screen moving?
Yes, sir, it is moving.
Okay, so shall I start?
Sure, sir, you can start.
Okay, so a very good afternoon to all the participants here. I am Sachidanand Singh and I am Scientist B at National Institute of Hydrology. And today I will be delivering a short webinar on what are the applications of Google Earth Engine, and especially for water resource management, where you can apply this tool. So let me start. So as we all know, GE is a cloud-based platform for planetary scale geospatial analysis, and that has transformed how we approach environmental monitoring currently. And it combines the multi-petabyte catalog of satellite imagery provided by various countries like USA or Japan or other countries, and it hosts all the geospatial data set. And using this platform, we can and through simple lines of code, we can simply operate on these satellite images, and then we can produce the desired result. And everything is done on the website itself, so there is no need to have very high-end systems for your computer, and it can simply work on Chrome. So when we talk about the key features, so like it has got the massive data repository in petabytes of dataset it has, and then it uses the cloud processing. So cloud processing means like online everything is processed using your websites only, using the web server only, and there is one client side server and your user side server, client side and suppose user side. Both sides servers are there which are utilized, and it is very much scalable, and it has very high speed, and you can use basic JavaScript also, and there is a Python tool also. Like using Python also you can use this tool, and and basic JavaScript is also there, and it is very much helpful in real-time analysis of dataset, because as soon as the datasets arrive, they get updated on this platform itself. So basically, talking about the core component, so there are basically 4 major steps that we do while we start working with Google Earth Engine. Like we first do the registration part. It is free of charge, and you can simply create your account, and I will share you the link from where you can create how you can sign up if you don't have the account. And then when you will create an account, a code editor will open, and there and that editor has all the interface where you write the code. I will come to this slide again in the at the later stage. So in the code editor, what you do, like you type all the lines of code, basic simple English lines of code you type, and you get the results. You get all the satellite data set images and all the processing part you can do by simply writing the codes. And then it hosts a huge data catalog, like it has a data set for all the Landsat series, then Moody's, then Sentinel, then climate related data sets, then some high resolution imageries, then topography related data set, night lights. A lot of data sets are there in the data catalog, which I will tell you at the later phase also in detail. And then there is a very good documentation, like using how to use this platform and how you start writing the codes. Everything is very well documented in the website itself. You have to simply visit that link, and then you can just start your programming part from very basic, from hello world to the end, to how to create an application. You can go from beginner to very advanced level simply by following their documentation. So these core components are there in this platform, which we try to utilize, and then we try to produce some result. Then comes the application. So like, as it has got the data sets of all the satellite imageries. So like, if you are from environmental background, or if you are from atmospheric, or from geoinformatics, or urban resources, water resources, forestry, there are a lot of dimensions in which all these data sets are used. In every dimension in which remote sensing is used, there you can utilize this Google Earth engine. So talking about this application, so like, the mostly it is used for the preparation of land use land cover map, and using some machine learning technique, and that is further used for urban sprawl monitoring, or checking the what are the deforestation pattern, or how the river morphology has changed. Like that, you can analyze the land use land cover using this tool. Then if you are talking about agriculture, so you can go for crop yield analysis, then precision agriculture. Like, you can even upload your own data sets, high resolution data set, and then you can start doing some machine learning. You can do some machine learning on that, and then you can analyze ki, okay, how much area is, which crop is there. So that kind of analysis can also be done. Then talking about climate and environmental change, then like, there are a lot of data set which gives you the information about the precipitation, temperature, humidity, all the climate and weather related data sets which are hosted are already present there, that you can simply write simple line of code and then analyze it. You can also go for ecosystem health monitoring. Like, you want to analyze the fish habitat, or you want to analyze the wetland. So that mapping can also be done using this platform. Then similarly, that can be used for wildlife habitat monitoring, like all the layers that are required for the habitat. Like, it could be NDVI for vegetation, NDWI for water, and some carbon data set, or some other air pollutant data set. All data sets that can be acquired using this platform, and that you can then use some GIS software, and then integrate all those layer and get your desired result. And it has a very good application in forest monitoring also, like how the forest areas are changing. There are some data set which are giving you the net loss in forest, net gain in forest over the past 20 years, 30 years. Then there are data set which gives you the forest fire information, like how much area is burned during the fire incidents, like during the disasters. You can even map the forest fire. Then talking about water resource, then you can go for flood detection. Then you can go for urban flood analysis. Could be, you can go for glacier monitoring. You can go for seasonal water flow. A lot of applications are there in which you utilize this platform. Coming to the water resource management part. So the water resource management part, we generally, since my background is also from the water resources, so I use this platform a lot. Like, if I want to, since the water resources people, they need the data for the precipitation, they need the data for the temperature, they need the data for the surface water. Then someone who is working on the glacier, they need the data for the glacier lakes. And someone who is doing for working for disasters, so they need the data for flood, then inundation. So a lot of apps are there which are being generally made using this platform. And And I will show you one by one ki how many how many apps people have created. So some of the examples I have already kept it here. Like for climate and remote sensing data set, there is very beautiful platform by the name Climate Engine. And if you will open that website, okay. So this is the basic website of Climate Engine that has been prepared using Google Earth Engine. It is powered by Google Earth Engine. And using this website, you get the climate information like rainfall, temperature, as well as you get the remote sensing, some of the remote sensing data sets also. So how to operate this platform? Like you have to first create an account there. Like you have to just log in using your Gmail account. And then there is an option like you can make a map or you can make a graph. Suppose you need a time series of rainfall. So you can select the option of make graph, and then you can select a point over your desired area. Suppose I want to know the rainfall of Dehradun in past 10 years. So what I will do, I will put this icon on Dehradun. I will select make graph option, and then I will select this native time series, one variable analysis, and here is the information ki what data set you want to use. Like you want to work on climate and hydrology. Since we want rainfall data set, so I've selected climate and hydrology. Then you will see ki a lot of data sets are there which are related to climate and hydrology. So if you will go through the data catalog page of this Google Earth Engine, then you will get to know ki there are a lot of data sets which give you the information of precipitation. Then there are some data sets which give you the information of temperature, some for land surface temperature. So likewise, a lot of data sets are there which are already numbered here. So suppose I want to use this CHRF data set which gives me the precipitation information. Then I will select this precipitation, and then I can select my date range. Like from suppose I want for the past 10 years. So I can select this year as 2015, January to suppose 2024, December. And just simply by clicking on get time series, and depending upon the data set requested and my area of interest, it will take some time. And see, within 10 to 10 seconds, you got the precipitation information of Dehradun, which you can simply download using this icon. You can download as CSU, download as Excel, and then you can create your chart, or then you can go for further time series analysis or some other kind of analysis. So likewise, this platform was prepared using Google Earth Engine. Similarly, if you want to work for some remote sensing data set, so instead of climate and hydrology, you can select this remote sensing information, and then it has given you the option whether you want to use Landsat 5, 7, 8 combined, or 5, 7, 8 individual, or you want to use the surface reflective data set or top of atmosphere data set, or you want to work with Modi's data set or VIRF data set or Sentinel data set. All the options are there. So suppose I want to map the NDVI time series. So what I will do of suppose I want to map the NDVI for my water body. Like I want to check ki how much NDWI is there for my water body. Suppose for example I am selecting some reservoir, like this reservoir I am selecting, and I want to draw the NDWI map. So I will select this option, make map, and then I will go with remote sensing, and then using Landsat dataset. Suppose I want to work for recent, I can take Landsat 9, and then I can select NDWI, and then I can select my date range. Like for this year only, if I wish to get the NDWI for the month of March, I will just select the date range for the month of March, and then I will click on get map layer. And you will see within no time it has created a NDWI map for my region. And this map, I can simply use this download button, rectangular region, and then I can draw a box over my area. Then simply I will click on download map layers. And one link will come which I will just click, and my NDVI image for my region is ready. Like suppose someone is interested in mapping the reservoir over over a particular period of time. So for that someone can just select the date range and just click on download. So every time they will get, for every month they will get the NDWI NDWI image of their region, and using that image they can calculate the area like greater than 0. They can take as threshold, and then they can get the area of their reservoir, and they can they can check if well, every year what is the reservoir surface area, how it is changing. That can be monitored. So using this platform itself, you don't need to code anything. Like all these platforms are code free platform, and you simply just click and download the result. Similarly, you can do with NDVI, LST, and there are various other indexes that are already present here. You can even download the true color composite, false color composite for your analysis. So this platform by the name Climate Engine is very much useful, which is generally utilized by the water resources people for downloading the time series of climate dataset, as well as for downloading the remote sensing datasets for long period of time. Then comes the other platform by the name Global Surface Water Dynamics. So I will open this thing. All these platforms are made using Google Earth Engine only. So like if you want to analyze global surface water dynamics, so already the people have retrieved those layer, and they have already added those layer, and they have given you a visualization like what this black color means, what does red color means, and you can simply select what you want to do, like interannual dynamics, or you want interannual dynamics classes, like you want permanent water gain, water loss from 1919 onwards to 2023, how much water, which area has lost its water, which area has gained its water. So through this app, you can simply analyze. Like if you talk about Ganga, so you can check how much region the water is having in the wet period, how much in the water is how much loss is there, how much water gain is there. So likewise, this app was prepared, and detail of this app you can visit through this link, and you can get key how they have prepared this app, as well as what is the background that is working to calculate all this water percentage. Then similarly, there is one seasonal water and ice dynamics for people who are interested in working with glacier dataset or ice dataset. Similar platform, they have created the seasonal dynamics of surface water through which they are analyzing the ice. So like how much area the ice has gained or how much area the ice has been lost. So they have tried to map the melt month, they have tried to map the freeze month, the number of month of ice. So these are the just app for the visualization. Through this you get to know okay, this much area seasonal water ice are there, or this much area seasonal water melt is there, this much area freezing water is there. So using this platform only, they have done all the pre-processing part, and they have hosted it on this platform. So GE, this Google Earth Engine not only allows you to analyze the dataset, it also allows you to publish your dataset in the form of a website. Through this, if you don't want to share your code, but you want to share your product, so you can create an app and you can share it to local people, and you can show what are the results that you have generated. Likewise, people have generated. Suppose you want to create surface water animation. So for that also, a different app was prepared. And you can just draw a new region. Suppose you want to analyze the, wait, I will just change the, suppose you want to analyze ki how much river morphology is occurring. So you can select the FPS, you can change the fade rate, and depending upon your user input, a thumbnail will be generated. Like thumbnail is nothing but an animation will be generated, and you can visualize ki, okay, in my region, this kind of change, the river is occurring, the river is showing. So this app also in the background, it takes multiple remote sensing data set from 1984 to 2018, and then it overlays every layer over each other, and then it checks ki, okay, and then it presents in the form of a visualization. So this is also a very good example where you can check ki how much river morphology has occurred. You can also use this the same app for suppose you want to monitor some reservoir. So you can draw a new region over a reservoir and new thumbnail will be generated that will show you how much spread area is increasing or the spread area is decreasing. Likewise, you can use this app. See, you can see the spread area is coming from here to up more. It is decreasing and then it is increasing. Likewise, this is just for the visualization that you can use. Similarly, one snow cover mapper was also prepared, and our team at National Institute of Hydrology, we are also preparing a snow cover mapper app that is at very high resolution of 10 meter. But this app was prepared using a Moody's dataset, which is at around 500-meter resolution. And here also you can draw a rectangle or draw a polygon over an area, or simply you can select a basin which they have given by default, some of the basin. So like these people have created the app for their own region of interest. You can also create when you are in an advanced level of Google Earth Engine. You can also create these kind of apps for your area of interest, and then you can give the region, and then you can change this shapefile to your area of interest, and then using this website you just simply tell the date range and then simply click on go, and it will draw a shapefile and it will draw the snow cover map of that region, maximum snow cover map of that region. Likewise, a lot of apps are there, and they have also given you the snow cover area time series, like how it is changing for that year, and then annual maximum snow cover, how much it is there, annual median of snow cover, annual standard deviation of snow cover. All these data sets are nothing but a basic coding which are being done at the background, and the data sets are utilized from the Google server. They are retrieving the data set of Moody's, which are already hosted in Google Earth Engine. You just simply need some line of code to write those data set, to call those data set, which I will show you also. An example also I will show you. And then you can analyze okay, how much change is occurring. Similarly, there are some apps for wetland and inundation mapping also. And but this wetland inundation mapping was done at very high resolution for USA. They have used NIP imagery, which are at around 1 meter resolution. Like they are at very high resolution. And then you can activate the inspector and just click on some watershed. And just by clicking on those watershed, you will get to know okay, what is that watershed ID, what is the name of that lake, how much area it is occupying, how what is the maximum water extent, and how the map looks like. So all those data sets like permanent water cover, water occurrence, maximum water extent, monthly history. Just by simply selecting that watershed, you get to know all those data sets. See, all the watershed of that region is mapped. But these are prepared using very high resolution map. But similar kind of app can be prepared for using Sentinel dataset, which are available for all over the world, as well as using Landsat dataset. Also, you can prepare for your region of interest. So likewise, people are creating a lot of apps and they are utilizing this Google Earth Engine for their research or for their analysis. Similarly, like UN Spider has also given a code to map the flood. So like this was one example set up on Bihar for 2020 flood. During July, Bihar has received a lot of flood. So this whole code was given already. The code is already there, and that how to convert it into app, all the process was already given. And this app was also created. Like you can analyze ki, okay, how much area has been there for the flood and how much number of people were exposed to those floods. So like we called it risk mapping or hazard mapping or susceptibility mapping. That kind of work can also be done using Google Earth Engine. And I believe we have one listener also, like Pulkesh has also created a very excellent tool to code or to create your to write your codes in Google Earth Engine. So that tools can also be utilized. Suppose you are very new to Google Earth Engine and you don't know how to write a code. So one tool is there. Wait, I will show you here. Tool created by Pulkesh. I think he's one of the viewer also. Pulkesh, are you there? I saw he was there. He was one of the listeners. So he has also created this AI assistant, which is an excellent tool. If you are very new to Google Earth Engine and you don't know how to write a code, so you can simply request key, okay, show me a Sentinel-2 true color image of New Delhi for March, and you just click on generate after giving your API key. Then it will generate a code which you can simply run. But if you want to learn, so before using this, if you want to learn, then you have to go through all those documentation. But first try to understand key how all the code is working, and then you start creating the apps and then creating and start doing your analysis. Okay, now so coming to the learning resources, like how you can get started. So like our institute hosts a lot of training all over the year. So you can visit our NIH-WHRC website and you can go through our training calendars. We recently had a training during June, and in future also we are going to have some training on basic of Google Earth Engine, where you will get to learn ki how to write a code, how to start with Google Earth Engine, what are the basic syntax of JavaScript, and how you can start programming. Then there is an excellent course for water resources management, Google Earth Engine for water resource management by Ujjwal Gandhi, and in his blog of Special Thoughts. If you will visit this blog, and there is a course on GE water resource management. That is also an excellent course to learn. I will just show you. Like if you want to start, okay, how to begin and to work to work in the domain of water resources, and you want to start for how to work with Google Earth Engine. So this tutorial is also very good, and it has various modules from basic to advanced, and you can simply click on one by one and you will simply get to know key, okay, how this platform is, what are the various tools and icon, what this stands for. And if you will complete this course, then also you will get to understand ki, okay, how you can utilize Google Earth Engine for water resources. So it has comprehensively covered all the theories and practicals related to Google Earth Engine for water resources. And there are some supplement examples for drought monitoring, hydrology, surface water, SAR dataset, as well as some time series analysis. So this is also a very excellent tool to learn. Then there are some tutorials hosted on this website, google-earth-engine.com, which you can also go through. They also host a lot of tutorial, and there is one primary source also which you can accept, and that all the codes will be saved. And it has all the chapters starting from JavaScript and Earth Engine API to exploring image, then survey of data set, then remote sensing vocabulary, and how to interpret images. A lot of chapters are there that you can go through and you can start learning Google Earth Engine. A lot of basic and advanced courses are there. So basically we learn in 3 steps. Like for the beginner, in the beginner stage, we just learn the basic programming, basic syntax, and we should have a background of remote sensing, like what data set does what kind of work. That information you must have before starting Google Earth Engine. A basic or knowledge of remote sensing should be there. And then you go with the intermediate analysis of mapping, reducing, uh, you do some statistical analysis, then calculating area, all that kind of work, then doing some machine learning, LULC classification. That kind of work you've done in intermediate stage. And after you have acquired those basic knowledge, then you can move towards advanced courses in which you get to know how to integrate those codes to advanced mapping, like how you can create some apps. And if you don't want to share your code but you want to share your product, then how to do that, how to make some interactive web apps, all that can be covered in the advanced stage. So you can visit this website also to learn the basics. And then there is one tutorial, if you are interested in learning Google Earth Engine using Python. So this very excellent tutorial by our Qingshu Wu sir. So his channel name is Open Geospatial Solution, and in this channel you have the tutorial number 0, 1, 2, 3, 4. Basically using GE Map, he has introduced a library by the name GE Map, and using that GE Map you can do the Google Earth Engine computation in Python. It could be in your workbook or even in Colab also. Some of the codes are very well executed. Using Colab, you can, or using Jupyter Lab, you can start working with Google Earth Engine. So this tutorial, using this tutorial also, you can get to learn about this tool. And then, as already told in the beginning, like the Earth Engine itself has its documentation page, where if you will go through from starting to the advanced level, it has covered how to work with image, like how to work with image collection, then geometry, feature view, everything, reducer, join, everything has been given in detail. And there are a lot of learning resources. Like if you want to work with machine learning, how to do supervised, unsupervised, and how to import raster data set, how to import shape files, everything. And then how to work with large data set, then how to create video, animation, everything is covered here in the Google Earth Engine page itself. So likewise, you can get to know about Google Earth Engine. And there are some other YouTube tutorials also. If you will go through YouTube, there are a lot of tutorials are there for basic understanding to advanced processing of various remote sensing dataset that you can go through. Now coming to the components of Google Earth Engine. So the first step that I told you, like working with, if you have any doubt, you can interrupt me in between and you can ask. If you have any doubt in the beginning, if you have any doubt, you can interrupt me anyway. Okay. So like as I was telling, the first step is to register. So that link I will share you. I will share with you. Like this link will be useful if you are a very new to Google Earth Engine and you don't have any account. Then how to create a new account in Google Earth Engine. Yes, I will be sharing the presentation. Okay, if people have asked some question, okay, can a digital twin model can be created? Okay, but I will come to your question one by one. Just wait. Let me finish, then I will come to this link which I have shared. Through this link, if you are very new to Google Earth Engine, you get to know how you can sign up to your non-commercial project, and then you can start working with Google Earth Engine. So when that page will open, when you have completed with the registration and sign up process, when the sign up process is complete, this page will appear. Okay. Now in this page, you will see there are total 4 windows are there, like left side, center, right, and the bottom panel. Okay. So, and here if you will see, there is one question mark here. Clicking on this question mark, you can have a feature tool here at the bottom. And this feature tool will tell you what all these windows are about. Like left window is called left panel, then middle window is called editor panel, right window is called right panel, then there is one UI root at the bottom, there is one search box there at the top, and there is one option to create a cloud project. So all these options they have already integrated. So like if you are very new to Google Earth Engine and you are not aware about this interface, then you have to simply click on this question mark and then go to feature 2. And then just clicking on next every time, it will tell you in detail ki what are the things that are there. So in this page, the left panel has got three parts. It has got one repo manager, repository manager, then one documentation list, and one asset. So in the in repo manager, what this repository has all your codes, like whatever the codes that you have written, it will be saved here itself. You don't need to save that code anywhere in your desktop. It will be saved in this platform. Then the doc manager has got all the documentation. Like documentation means key all the syntax that we use using JavaScript that is present in this doc. So all the algorithms and their syntax, how to call them, how to use them, that is present in the docs. Then this asset contains your own data set. Like if you have your own shapefile of your area that you can upload in this asset. You can upload some geotiff imagery if you have some high resolution or some other data set which are not in Google Earth Engine platform, that you can upload it here. You can upload some shapefile. You can create image collection, and you can even upload some image collection also. So likewise, asset contains all your own data set. Docs has inbuilt syntax, and script is all the code that you write. All the code that you write is there in script. Okay. Then coming to the middle part also has some of the tabs like get link button, save button, run, reset, and app. So get link button is also very important button. Like if you are working on some code and you are getting some error, and but you don't know how to resolve those error. So you can click on this get link button and one URL will generate, and you can share this URL to any other person to whom you know कि he can solve your problem. So you can just copy this URL and share it with the person, and you can ask कि, okay, what the problem is coming and how to resolve it. Like anyone who has this link will have the access to your code. All the code will be visible to the person to whom you are sharing your link. Then the one button is there to save your code, that will be saved in your script. Then one button is there to run your code. Then there is one button to reset. Like if you want to remove all the results that you have prepared, then again you want to run the code. For that, this reset button is there. And then there is also a button to create an app. So this app, which I told you, will be when you are in an advanced level of learning at that time. And if you don't want to share your code, but you want to share your product, so Earth Engine itself has a feature to make apps. So you can create various apps using Google Earth Engine, and that app can be directly shared with anyone. And sharing that app will not share your code, but it will share your result. So likewise, you can use this app button. And this panel, this whole center panel, it is the place where you generally write your code. So the code writing is basically done in JavaScript language, which is very similar to English language. Like you write declare some variable, and then you declare some name of that variable, and then you assign it to something. Like you can assign it to some shapefile, you can assign it to some image, you can assign it to some image collection, and likewise you can proceed with the coding. So this center panel is mainly used to write your code. Then coming to the rightmost panel, it has got the inspector button. Inspector button is similar to your info button, which is there in QGIS. Like if you click anywhere on the screen with the result, it will tell you the information of that pixel, what that pixel is showing. Since I don't have any layer drawn here, So it is showing me just the information ki what are the coordinates where I have clicked my mouse, and then at what zoom level I am there, and what basic scale it has been zoomed. So inspector button is like info button of ArcGIS or QGIS. Then comes the console button. Console button has all the data which you have written in the form of print. Like you have written here print here. Whatever things that you write with the help of print, it will come in the console part. Also, the things like any error which is there in your code, so that will be displayed in console. Ki, okay, line number this has this kind of error, this unexpected token or memory capacity exceeded. That kind of error is shown here in console. Then coming to the task part. So task part contains all the layers which you have exported. Like if you have exported some image, you have exported some Landsat imagery, or you have exported some DEM, that get exported to your drive, and from the drive you can download it. There mostly all the exports tasks are handled in the task part. And the bottom part is called UI interface part. And this UI interface is will display all the things that you have written by the name map.add layer. So whenever you will write map.add layer, the result will come in the bottom part. That image will be displayed at the bottom, or some shapefile will be displayed at the bottom. And you can change the base map to terrain or simple map, or you can even change the base map to satellite, and then you can check okay, you can check with your image whether it is matching or not, like that. There is also an option to draw a polygon, point and line using UI interface. So if you want to working, if you are working with land use land cover classification, so these tools are mainly used to give the classification. Like you want to train that data set. So through point line and polygon, you can train your data set, and then you can create a map. And this plus minus is mainly used for zooming in and zooming out. So I'm not telling you in detail because the session is very small for this whole Google Earth engine. So, but this was just to give you an overview, okay, how this platform looks like, and what are the things that you need to keep in mind before starting with this platform. So first I will take some of the question, then I will proceed. Okay. First I will take all the question like, okay. Can digital twin model be created using G, like if to have predictive analysis for flood risk? So will it be possible? I'm not aware about this digital twin model using GE, but yes, you can try for this flood risk mapping are being done using Google Earth Engine. People are creating layers, and then they are using some machine learning or some AHP or some MCD analysis like AHP or fuzzy AHP or some other kind of multi-criteria decision algorithm people are using, and then they are creating risk map of floods. So that kind of thing could be done, but how can it be done with digital twin model? This I'm a bit unaware, so that needs to be explored more. But yes, you can go with predictive analysis for flood risk. That is possible. Okay. Can we measure the depth in lake using GE? Till date, though, ultimately data sets are not there in Google Earth Engine. But yes, you can get some ultimately data set from some other platform like Saral Altica or some other platform. And that data set, if you have those CSV file, converted CSV file, that you can import as table here. And then you can create some DEM or the bathymetry of your reservoir or any river that you are working. But currently, altimetry data sets are not there. I will show you the data sets also. Like to everyone, I will show you what are the data sets that are being there. So depth in lake currently nahi hai, but yes, it might come in future, but currently don't have. And Pulkesh has, yes, he's attending the call, and yes, he has shared the link of his AI assistant, which I believe is very excellent tool that he has created for beginner to advanced level. Everyone can use this tool, and using that tool, you can simply, if you don't have any idea of coding, also still you can ask the agent to write your code, and that code works, and even you can debug your code also. And he has also, I think he has given some YouTube tutorial also how you can uh, learn those uh, uh, AI assistant. So that is very excellent tool that can be used. We'll get this presentation. Yes, I will be sharing this presentation. Don't worry. How we can get the access to the links. So don't worry, I will be sharing the presentation with all the links will be active. So you can use that uh, uh, PPT. Can we get the snow data? Like snow data, you need to the snow data. If it means like already hosted snow images, like you can use NDSI for your analysis. You can call Landsat dataset or Sentinel dataset. Then you can generate NDSI, and using that NDSI, you can point out. You can take a threshold of around zero point 0.3 to zero point 0.4, and greater than 0.3 to zero point 0.4 is generally considered to be snow. That snow data you need to generate. That will be a better approach to generate snow data using NDSI. That can be done. But those snow data is like that, or you can use Modi's also. Modi's data sets are there that can also be. If you are working with for a very larger region, then Modi's resolution is also fine at 500 meters. For a high resolution, it is better to go with Landsat or Sentinel-2 data set, which are at Landsat is at 30 meter and Sentinel-2 is at 10 meter. That can be used. Yes, yes, I will share. I will share this PPT. Don't worry. Sir, with spatial animation of river and surface water can make temporal map along with it there. Like spatial animation is it's in the form of a GIF, but you want to make a temporal map along with it. So, like to if you want different images, like for different images, you need to write a code to export every images. But that GIF is having the combination of all the images. Like one more, you can in my website itself also I have hosted. I've created a web app. Like if you want to do some kind of time lapse generator, I have created a basic app is there. Like if you want to suppose generate a time lapse of river morphology. So you can use this website also. This is my own website and this is my own app that I have created a basic app to create a time lapse over an area. Takes time because it is using Landsat dataset. So it will take some time. I will come back to this page later stage. But yes, so temporal map, if you want individual map, then you need to export it using the JavaScript code. But if you want a combined map, then that GIF can be downloaded. That surface water animation GIF can be downloaded. So that will give you the animation. Sir, application of GE in groundwater monitoring. So currently, see, GE contains the data set of all the remote sensing data set, and as you know, the remote sensing mainly does the surface mapping. Okay, mostly it works with surface mapping, but yes, for groundwater, they have a GRAVE data set, which they have prepared using the gravity method. So using that, they are indirectly telling you the information of groundwater, how it is changing with time. So that GRACE data set you can look into for groundwater monitoring. But currently, rest groundwater analysis is done through some model. Like you can create a water budget model, and then precipitation minus runoff and minus infiltration will be equal to groundwater. That kind of equation can be used to indirectly get the information of groundwater, but directly getting groundwater is not possible through remote sensing. It is generally done indirectly. Okay. Can I get storm search data from here? Okay, I will search. I am also not aware whether storm search data sets are there or not. So to check, like whatever your interest is there, like if you want to work on storm search or you want to work with forest cover area, so the page is this data catalog page is there. The link which I will be sharing. In this data catalog, it has got a lot of data set, like it has got surface temperature data set, climate data set, atmospheric data set, weather data set, Landsat, Sentinel, MODIS, then geophysical data set like land cover, terrain, agriculture. A lot of data sets are there. You need to search, like if you want to work on storm, if it is there, then it will be shown there. But see, related to storm, there are some NOAA dataset, but I believe it is not for Indian region. But there are some subtropical cyclone of subtropical storm intensity and some dataset they have given. But it might or might not be for India. But that storm surge which you are asking, some hurricanes dataset and other storm datasets are present there. So whatever dataset which you are interested, you need to search it here. Suppose you want to work with snow, just search it here snow. So all the dataset which are tagged with snow, that will appear. Like MODIS datasets are there. Terra snow at 500 meter, then 8 day L3 global dataset, Terra daily dataset, Aqua snow, Landsat 7 collection, 8 day NDSI composite. All these data sets are there. So whatever your work, whatever the topic you are interested, you need to search it in the data catalog. If the data set is there, then if the data set is there, then that data set could be utilized here. Can GE be used to develop dynamic maps that will update with time? Yes, people are attempting to develop dynamic maps. Like in that case, you need to, there is an option like when you build an app, so there is an option to give a date calendar. Instead of giving the date as an input, you can give a date calendar, and through that date calendar, whatever date that you are selected, if the data sets will be there, it will be generated. So yes, dynamic map can be generated using Google Earth Engine. Is there any model for drought monitoring and prediction? For prediction, we don't have, but for drought, like there are a lot of index that you can create related to drought, like VCI and some drought index are there, SPI. So that index can be created. Even you can use that climate engine platform that I told you in the starting. That climate engine platform also has some of the pre-built data set related to drought. So you can simply search here drought and you can check key if some data sets are there. So gridman drought data sets are there. Cone drought indices, Keyman Brime drought indices. See, so these are the data sets which are related to drought, but you need to check whether they are available for your country or not. A lot of data sets are there, but related to soil moisture data sets are there, which you can indirectly relate with drought. But and some drought indexes also, some data sets are there. But it might not be for Indian region, but it is there. Data sets are there. Sir, can we extract mid-channel point bar of a river through GE? Yes, there is a code. Actually, I don't have currently. I don't have a code, but there is one organization in US, like in World Bank, related to World Bank. There was one project in which they are working with this mid-channel point bar. And they are working with river sedimentation analysis using Google Earth Engine, and they have developed their own code, their own JavaScript code, and which they are integrating with Google Earth Engine, and that code is around 4,000 lines of code are there. So that was a very rigorous code, but they are trying to extract this mid channel as well as this bar with that sandbar which are along the river banks. So they are trying to generate those data sets. Even for that point bar and mid channel, if you want to do it simply in simple words, what you can do, like you can go with simple classification. Like for some time period, you select a data set, could be Landsat or Sentinel, and then you try to use machine learning or like some which are there already there, like random forests are is there, SVMR is there. So you can simply train your data set over that point bar, and then that can be used to extract the information of that point bar. That can be tried, but people are developing a dynamic algorithm which generates for every month and it extracts the data set. So there are some attempts that has been made. Yes. Suggest how to practice and get more useful with this. So for that, I have shared some learning resources. Like I have shared some learning resources. All the links I will be sharing my PPT also. So using that learning resources, you try to first get the basics of Google Earth Engine, ki how to start, and then it is totally depending upon your practice, ki how you are practicing this platform, and you will get to learn in very short time. It is very simple. It is not very tough. You just only need to start. The writing code is like writing in an English statements. It is very simple, but you have to just try writing to web portal. To is there any option in Google Earth Engine so that we can directly send the data set to the web portal to show? Like if you are asking about uploading the data set if which you already have, that can be done in this asset tab. Like in this asset, you can upload your own TIFF file. Like if you have some high resolution drone data set or some high resolution list 4 data set, that you can simply upload here, and then that data set you can call here. You can simply type map.add layer, and that data set will come here. And using this get link, you can share that code, or you can create an app and then you can share that data set to the web portal. To get this in, okay, please fill this feedback form also, everyone, those who are there. Can I analyze the groundwater by Graves dataset? Yes, yes, yes. You can analyze groundwater by Graves dataset. Graves datasets code is also there, and you can simply search here Grace, GRACE. The only thing is with Grace is that it is very coarser. It is not at a very high resolution. It is a bit coarser data set. So if you are working on a larger basin like Ganga River Basin or some major basins of India, that in that case you can use this, and it gives you the monthly information of data set from 2002 onward to 2017. I think some recent data sets are also there. Up to 2017 they are showing. Okay, and like how to use this data set. So every data set, whenever you will open and this data catalog page, every data set has its associated code at the bottom. You simply need to copy this code, or you can simply click in open in code editor, and how that data set looks, it will directly come here. All the code will be coming here, and you just need to click on run, and you can visualize this data set. And using this inspector, you click on any pixel, and it will give you the value. So I have called this Grace data set, this one, Grace mass grid, and it is giving me the LWE thickness value as minus 0.284. That means it might be decreasing. This is for minus 357. So using this data catalog page, for every code, for every data set, there is a code. Like you want to work with basic, for the basic, I am telling you, like you want to work with SRTM digital elevation model. So at the last, you will see there is a code. You can simply paste that code and run. So it is giving you the slope, as well as if you will just type a line to show you the elevation also. So just for writing single line, like you are calling this image, and then you are selecting that elevation band. you can simply, just by writing this map dot add elevation, just by writing this two line, you will get the elevation for whole of the world. So it is like this, since it is hosting all the data set throughout the world. So just by writing single line, one or two line, you will get to know, okay, how much elevation is there. And you just using this inspector button, you will click anywhere. Since this code is calculating elevation as well as it is calculating the slope. So both data sets are there, which are displayed here. And just by clicking anywhere, you get to know, okay, elevation at that point is 117 and slope is 77 degree. Just by writing these 3 to 4 lines, you get the information of elevation of whole of the world as well as information of slope. So when you will learn this tool, you will get to know its advantage. Like the similar task, if you had done in ArcGIS or QGIS, it would have taken a lot of time. Like you would first have downloaded the data set from that USGS website, and then you need to mosaic all those data set, and then you need to clip for your area of interest. All that clipping, mosaicing, everything can be done here. Even the value extraction can also be done here, and you can simply export the DEM for your area of interest. Likewise, this platform is used to simply do the calculation and analysis in very efficient way. Can we extract climate data like TRMM or yes, you can very easily extract climate data set like TRMM and ERA. You can even use that climate engine if it has it has got ERA data set, but TRMM data set is not in climate engine. For TRMM data set, process will remain the same. You need to go to that catalog page. Whatever data set you need to work, you just search it here, TRMM. You search whether it is there or not. The GPM TRMM will be there. Yes, TRMM will be there, is there. And code is also there. You simply click open in code editor and then click on run. And depending upon your need, like you want to know it for 2024 to 2025 April, for example. You can simply click it here. You can just simply change the date, and you also need to check whether the data set is available for that reason. Whatever data set that you are working, you need to check for how much data it is available. Like it is available from 1998 to 2019 only. So you cannot do it for 2025, but yes, you can do it for 2015 and some other area. And suppose you want to know it for India for 2015, just use this inspector, and suppose I want to check for Dehradun. I will click it here and I will get to know precipitation for this period of time. It has generated me a time series, which I can visualize here. Okay, from April 1 to April 30. Precipitation, HQ precipitation and IR precipitation. Mostly we are interested with precipitation. You can even remove this thing also. In today's tutorial, I am not telling you how to write a code or how to do the coding part, because time is very less. I think already we have passed the time. And but this platform, you remember, it is very interesting platform, and you can start by your own also, and even you can attend our future lectures or future sessions, and you can even go through YouTube, and there are a lot of tutorials are there that will help you in learning this platform. I am just showing you its application, how you can utilize this. See, just by clicking at a point, I get to know the hourly rainfall for my region of interest, and which I can download as CSV. Likewise, TRMM data sets are also there that you can simply search. Hot and cold pixel selection. Actually, I'm not aware if you are asking about it is related to temperature or it is related to some other error or something. It's hot and cold pixel. If you are working about talking about temperature, then for that you need to select the temperature data set, and then you can get the threshold of greater than 35 or 40 for hot and less than 15 or 10 for cold pixel, if you are talking about that. But I am not sure about this term. If you are talking about some errors like paper and salt and pepper error, इसकी तरह अगर ये कोई word है तो I'm not aware. But for that hot and cold, if you are talking about with respect to line surface temperature or air temperature, for that you need to get the temperature data set. You give some threshold of some temperature, and then you can analyze how many pixels are there in hot and how many pixels are there in cold. Okay. Can we get the recording of the session? So I am not aware about the recording. Antika can tell you about this.
Yes, it will be uploaded in our YouTube channel.
Okay, fine. So
We can get it.
Okay. So it will be there in YouTube, so you can refer. The screen is not visible. Okay. Was my screen not visible?
No, it was visible, sir.
Okay. So Dheeraj sir, please you just check, maybe some internet issue might be there because it was visible. Get the recording. Okay. Thank you so much. Is it possible small demo of GE AI assistant use? Okay, fine. Since the developer has only requested me to show, okay. Like I can show you, like if I want to write a new file, demo AI. Okay. So I have written a new line of demo AI, and I already have that Google extension installed. And I have my own Gemini API key, which I have already pasted here. And I want to write a code like generate a digital elevation model using SRTM data set. I'm writing a basic code like generate a digital elevation model using SRTM dataset, and I clicked on generating. So it will send the request to Gemini, and see within no time it has created a beautiful, I think it has even created an app kind of interface. See, it has created the digital elevation model using SRTM90 dataset. It has already given all the visualization parameter. It has centered over to a region. See, just by writing a single line. And if I want to like add a title to this code, I can even modify this code just by writing add a title to this code. So this AI assistant will simply handle all that part. And see now global SRTM digital elevation model. Title has also appeared with all the label information. So I believe for those who are very new and don't know and are not don't have any time to learn also, but for them this tool is very much useful. We are so already using, but my suggestion will be that first try to understand the basic, whether the code is working fine or not, what it is doing, and you can take the help of any AI model. You can use this AI assistant. Even you can use other assistant like Chat GPT also, or some Grok or DeepSeek. But they will surely help you in writing your code. But try to go through the basic also. Like you must know whether what this line is doing, why it is using dot, why it is taking this kind of value. So that basic syntax information and basic logic you should be aware. You don't blindly believe ki whatever it is giving it is correct, because the analysis should be from your side. The codes could be generated through some AI, but the analysis, what it is depicting, what the results is showing, that you should also be aware कि, okay, it has generated this thing, whether it is correct or not, that totally depend upon you. All the AI assistant has this disclaimer कि the data set generated are AI generated, so you need to cross check and verify all those data sets. Okay, so just keep that in mind, and you can use this tool. This is very excellent AI assistant. NDVI and LFT. So NDVI, there are some data sets which are already hosted there. The NDVI data sets are already hosted that you can even directly use, or you can use some code of normalized difference, and then you can use Sentinel or Landsat dataset and then generate the NDVI maps. And for LFT, you can use Modi's dataset that is already there. And using Landsat dataset, some codes are there that can help you in generating the LST, land surface temperature, using Landsat datasets. So they are already there. Can we download them from here? Yes, yes, yes. You can easily download them from here of any region of the world, and code is like the same, like it has already like this code using this AI assistant already. The dem code is there, so I can write modify this code for my area of interest as rectangle and export it to drive. You can simply use that export table to drive command, and then you can give your area of interest, and then them can be generated. See, this clip dem has already AOI क्या है यहाँ पे? Okay, it has already created an AOI for this region, which I can simply drag and change to my region, or even I can draw a new AOI. Like I want to download the dem for Himachal or Uttarakhand. Okay. It will take some time because the area is big. Wait, I will delete. I will create a box. The name AOI. See, it has already clipped the dem for my area of interest. And in the task, you will see here in the task, SRTM dem is already there. I will just click on run, and within few minutes or within few seconds, depending upon my area of interest, that dem will come in my drive. So yes, it can be used to download the export the dem. You can use it to export NDVI, NDW, all the remote sensing indices that can be generated and exported. You can export the precipitation, climate, the data sets which are there already there in Google Earth Engine, that all the data sets can be exported. Provided you are not exporting for a very bigger region, like you are not exporting for whole India or for whole big state. For your smaller basins and smaller area of interest, it works. It works very good. Can we download with Legend? That using style you can download with Legend, but that is not required, because when you will export the image, that will come in the form of TIFF itself, and that visualization will not be there. You can, for creating maps, it is better you use some GIS software like ArcGIS or QGIS, and there you can draw your own legends, and then you can export. Or for that, or if that thing is generated, you can simply take the screenshot also, if you are fine with that legend which is already displayed. No, 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 no. This is not available as WMS or other desktop server. ArcGIS and QGIS have their own extension of using Google Earth Engine. ArcGIS also has its Google Earth Engine extension, and QGIS also has Google Earth Engine extension. That extension can be used, and in that extension itself, you can write the Google Earth Engine code and you can process everything in your QGIS or ArcGIS. Especially in Arc Pro, it is there, and in QGIS, it is there. So the layers are not as not in the form of WMS. It is not there in the form of WMS, but yes, in ArcGIS or QGIS, you can simply use the code, basic code, and you can start working with Arc Pro with Google Earth Engine. Can we work with future climate in CMIP data? Yes, I think it is there. It is there. CMIP data sets are there in Google Earth Engine. You just go to the catalog, search it here. I think it is there. The recent one, SSIP, is also, I think it is there. CMIP 6 datasets are there. See, up to 2100 future dataset from 1950 onward, it is there. NASA Next, and all the bands are there. Precipitation bands are there. Surface long radiation, wind speed, it is there. Actually, SSP. Some SSP datasets are also, I think they have ingested this SSP3. Shared socioeconomic pathways datasets are also there. So yes, climate CMIP datasets are there. It is there. Okay. Any other question? So the whole session was just to give you one brief overview. Like it was not like a detailed session on Google Earth Engine, like how you can start working. It was just to give you an overview, okay, how this platform works. Since the time is also like we have only 1 hour, 1.5 hours. So everything cannot be completed in a single session. But yes, keep looking at our future training courses in which we do organize 5-day training courses, 3-day training courses on Google Earth Engine that you can attend, and then from there you can learn. And yes, I have already shared the resources. From there you can also start learning the codes. You can also use this GI AI assistant for your work. Okay, any other question? Thank you for your wishes.
Thank you, sir, for this insightful session. It was an
Thank you.
excellent session.
Thank you,
And
Indika, for inviting. Actually, the time is very less now. We cannot
yes,
teach everyone like how to or
hmm,
code everything, but that can be done in our later programs.
definitely, sir. Definitely, we can organize a training program as well.
Yes, yes, yes. That will be more useful. Like people will get to know how to work with this platform.
Sure, sir. Also, thank you, Pulokesh, to share that tool, which is very useful.
Yes, yes. It is very useful. I'm very thankful to him, and
Hmm.
this he is doing very great with that too. Keep on updating, Pulkesh. We are using your tool, and please keep on updating. We are very much thankful for you. You are saving a lot of our time for the analysis.
Can I speak, sir?
Yes, 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 please.
Sir, I have added the voice option. That means
Ach-
no need to type. You can just speak.
oh, oh, nice,
It,
nice.
it will understand, and it can understand any language like Bengali, English, Hindi, any language.
Yes, I would request Antika, like next time you can invite him also. Like he can also give a
Okay.
demo on this GI AI assistant or whole tool. Like he will be very
Sure, sir.
very useful session will be there for us.
Okay, sir.
Thank you, sir,
Definitely
for
we'll
the
do that.
informative session. It was a really a nice session for the beginners.
Thank you, thank you, Pulkesh.
Okay, so with that, we are officially concluding our today's session. Thank you everyone for joining. Thank you all the participants, and I request everyone to kindly fill out that feedback form. And also, just to clarify that the people who are filling out the feedback form can get the PPT. I will share that in the mail also. Okay, so
Oh,
please fill out that feedback form. Okay, sir. And how will you send the PPT? Like, are you
Uh,
sending me?
I will, I will share it with you. You can share it with
Okay.
anyone
Okay,
who is.
okay. Sure, sir.
You might have the email details of the participant.
Hmm.
You can
Yes.
email them also, like if you wish.
Okay, okay, sure, sir. Thank you, sir. Thank you for joining. And thank you,
Thank you.
everyone.
Thank you for inviting. BCG sir also, please, I'm very much thankful to you
Mhm.
for this session. Is it? Okay. Thank you,
Sir
Antika.
actually is not here.
Oh,
He's
fine,
in
fine,
a
fine.
meeting.
No issue, no issue. So thank you
Okay.
everyone for patiently listening and asking your questions. And we shall connect in future also. Thank you.
Okay. For more exciting webinars, I would request everyone to follow the LinkedIn channel of SAIARD and NIH also. Okay.
Yes, please.
So, okay. Thank you, everyone.
Okay.
Have a
Thank
good.
you. Thank you. Thank you.
Thank you so much.